Hey everyone, I hope you all are safe and doing good. So, in the previous lectures, we have discussed methods in Java, and this lecture will discuss arrays. What are arrays in Java? And basically, first we will see why we need arrays. That thing is important to understand why we need arrays. Then we will see what are arrays, then how to declare array, how to initialize an array, how memories are, memory representation of an array, how the elements of the arrays are represented in the memory, and then how to access those elements, how to calculate the address, the formula to calculate the address, and these things we'll see practically also in this lecture. Right. Now, first, let me just ask you one thing. If I say I want to store marks of one student in my class and marks are 98, how you will store in programming kind of thing? You just say that just declare a variable like int and maybe marks as equal to 98. Simple. So in memory, somewhere like there is one block of memory would be allocated. The size is it is of int type, so 4 bytes would be there. Suppose addresses, suppose 1000 or any address can be there. It is in hexadecimal form, but we don't know exactly. So I'm just for simplicity purpose, I'm assuming that address is 1000 or 500 or any address you can take or 2000, any address. There we have this 98. Obviously, this would be stored in binary form, converted into 32-bit binary form, and then it would be stored, right? Actually, and the name is marks. So the name of this is marks. So three things we have with the variable. This is the logical name, the address, and the value, right? Now, I want to store marks of second student. What you will say, ma'am, just create second variable. Like suppose this is marks or like mark 1. This is same like marks 2, and let's suppose 97 marks are there. Like this. I want to store marks of 5 students. So what you will say, just create 5 variables, simple. But now the twist is, in my class I have 60 students. I want to store marks of all the 60 students. Then one way is to create 60 variables and store marks, but that is definitely not a good idea. Because okay, there are 60 students only, but suppose I want to store some data of 1000 customer or 500 or 1500 employees, then obviously we cannot create 1000 variables and store data, something like this, right? So there we use some different kind of thing. One is array we can use. There are some more ways also, like list and many things are there that we'll see later in this chapter, I mean in this course when we'll move further. But the simplest one is we can use arrays, right? Under a single variable name, we can store, suppose in my class I have 60 students. So under a single variable name, I can store marks of all the 60 students. No need to declare, no need to create 60 variables. And that is how using arrays. So simply I can do what? You have to tell like the data type, int, any data type, primitive type you can take int, float, double, or you can say boolean, short, byte, anything, right? Even string is also right, allowed. That thing I'll show later. So first let's take int only, and then these brackets, square brackets. Okay. Then name of the array. Then simply name I'm taking suppose marks. This is how you can declare an array. Okay. Int means the data type, whatever I will store in this array. Array name is marks. Array name is marks. So I will store int data type, int data only in this marks array, and these brackets indicate that this is an array of type int having array name marks. So this is just declaration of array. This is just a declaration, right? No memory has been allocated right now. If you simply write this, no memory allocation till now, it is just declaration of array, right? This thing I'll show you. Don't worry. Okay. Now, one thing is, obviously you have to tell like how much how many students mark you want to store in this array, and that thing we can do. And this you can write something like this also, like int marks, and this is also valid. The square bracket can be after marks, both are valid, but this is like more of in C we can do this thing, and this is C style and this is Java style. So this is modern kind of thing. In Java we generally use this syntax. You can use this also, it's fine, it will not give any error, but I will use this, okay, in Java. Now obviously you have to tell like marks of how many students you want to store, the size, right? So this thing we can tell something like this, like int, like this, then marks is equal to, is equal to new keyword, then the data type again, int, then in bracket suppose 60. So this line basically is about instantiating an array. So here we are simply declaring the array, here we are instantiating the array. Means we are actually telling the compiler that to allocate memory for this array. For how many student, or for how much data I want to store, the size is 60 I have told. So this thing you need to tell at the compile time only while creating an array, the size of the array. The size of the array is 60. So 60 int type of value I want to store in this array of name marks. So this line will instantiate this array, means memory allocation would be done for like 60 students marks, or 60 int data type, 60 int numbers, or 60, like you can say items of int type, right? So now if I say what is an array, can you simply say, and it is simply a data structure. Means data structure means simply how the data is to be arranged in computer memory, and array comes under data structure because simply we are arranging the data. It's simply collection of data. In this array we are having marks of 60 students, it's just collection of marks of 60 students, right? So array is just a collection of data, we are just arranging the data in some way, and that's what data structure do basically. So array is a data structure, we can say, right, in Java, or it is the most basic data structure. There are so many data structure we'll be discussing later, but it is the most basic one, array, right? So array provide a way to store and access, see, collections of elements of same data type. So first we can say, and in Java arrays are treated as objects. This thing you need to remember. Arrays are objects in Java. In Java I am telling you this thing because array is a basically a special class in Java. So whenever you create this kind of thing, so this marks is basically an object reference. It's not like that, we can say that actual array object, but it is just a object reference. So basically it's an object, right? Like in the previous case, I have told you one thing, when we were having a class and when we were creating the object of that class or instance of that class, right? So in that case, that name is what? Object reference. We were passing, we were having a demo class, so demo D. So D is what? Object reference, having the reference. The actual object is in the heap memory, and D is just object reference, which is going to reference the actual object, means basically storing the address of the actual object, and D is stored on stack. So same concept is applied on array also, because arrays are also objects in Java. So this is object reference. How these are stored in memory, I'll tell you later, don't worry, right? But for now, I guess the definition is clear to you. What is an array and why we basically need array? So we can say that an array is a fixed size data structure, or you can say array is a data structure having fixed number of elements of same type, right? That holds a collection of elements of same data type. These points are important to include the definition of the array. It's fixed size first and collection of elements of same data type. These two things are very important, right? Okay. So it's like basically a container, or it's like a container object. You can say object also. That is also fine. If you say in the definition, array is a container object which contains fixed number of elements of same data type. That is also fine. Or array is a data structure which contains fixed number of elements of same data type. That is also fine, right? So as a array is an object also, is a container object that stores multiple values in a basically sequential manner, right? So sequential manner means all the elements in the in the array is stored in contiguous memory location. Means one after another. Like suppose I have in an array. Suppose I have these elements 1, 2, 5, 4. 4 elements in an array. How to store? I mean, how to initialize an array, that I'll show you. But for now, let's take in an array I am having 4 elements. So in heap, in memory would be allocated, and these elements are stored in contiguous memory locations in a sequential manner. First 1, then 2, then 5, then 4, something like this, right? And these are of type int, right? So suppose this first address, the base address, or the address of the first element, or this block has been allocated how many bytes of block? How many elements are there? 4. Into each element takes how many bytes? These are of int type, so 4 bytes. So 16 block of memory has been allocated, and the starting address of this memory is suppose 512, or suppose 500. Suppose 500. 500. So the next element would start from 504, then 508, 512, like this. So these are in contiguous memory locations, sequential manner. It's not like that at one element of array is at the memory address, suppose 500. Obviously, address is in hexadecimal form, but I'm just taking 500. You can take any memory address. And next address is at another memory location, suppose 1000. Next is at another memory location, maybe suppose 5120. No, these are in sequential manner. So this is one more property of array, characteristic of array, that elements are stored in contiguous memory locations, like this only. Okay. Now, I think definition is clear to you, and these are some characteristics, like first fixed size. So arrays are of fixed size. Once you create an array, its size is fixed. You have told at the compile time only, when you are creating an array, how much element you want, the size 5, 10, 60, 20, 100, whatever you want. And that much memory would be allocated for that array. And that size is fixed. You cannot change that, right? It's not like that you have created an array of size 5 and now you want to store here 6 elements. It will give you error. Or if you want to remove one element, like I need only 3 elements to store, so just remove 2 elements. No, that is not allowed at runtime, right? If you want to change the size, at the declaration only you can change the size like 6 or 10 or something else, and then again recompile it, and then you can do this thing. Okay, I'll show you this thing. See, in some cases, like if you are aware about Python language, and there is one concept, vectors. If you heard about this, vector. So these are not of fixed size. If you have declared a vector of size 5 initially, and you want to now store 6 element, then you can store 6th element, and automatically the size would be increased automatically. You don't need to specify that I want now size 6 or 10. No. These are of dynamic size. So automatically by the compiler, the size would be increased. But in array, it is not the case. Array is of fixed size. This is some kind of limitation in array. And rather than this, we have some dynamic concept also in array. That also we can do. We have array list or some other data structure also that we can use if you want this property, like dynamic type of property. Like if you want dynamic size, then we can use something else. But arrays are of fixed size. Second is what? Same data type. Arrays all the elements in an array must be of same data type. Suppose you have declared an array of type int. Now you cannot store in this array a float value, double value, boolean value, or any other data type value. That will give you error. We'll see practically all these things, don't worry. And the elements in the array are stored in a specific order, like I have told you, in a sequential order. So when you access these elements, it would be very easy. How to access? You just have to use the index. Indexing of array starts from 0. So like 0, 1, 2, 3. If you want to access any element, so you just write down the name of the array. Suppose name of the array is A. Suppose, I don't know. So A, in this square bracket, just use the index. Suppose I write 1. So it will give you the second element, because index is 1. It will not give you the first element if you say 1. 1 is index. Index start from 0. So it will give you second element. A of 2, it will give you the third element. A of 3, it will give you fourth element. If you access A of 4, it will give an exception, array out of bound, because that is out of range. If you access A of 4 here, the range is from 0 to 3. 1, 0, 1, 2, 3. You cannot use 4. So it will give you an exception, array out of bound exception in Java. Right? So now I guess till now it is clear to you. Now, why do we need arrays? So one thing I have told you simply, you can like quickly access individual see, first let's see this point. Efficient storage. So array provides you a way to store all the related data at one place only, right? Because all the array elements are stored in contiguous memory locations. So it's like when you want to access the elements, it will give you easy access, as well as it is an efficient storage, because it provides you a compact way to store and manage multiple related data values together. Okay. So they are more optimized for memory allocation and access. So arrays are designed in a more optimized way. As well as accessing of elements is very easy. You can directly access any element. Just you have to use index of the array. And you can directly access the array elements. You don't need to go step by step. Suppose like something like this. In linked list, in data structure, you have to go step by step. Suppose in an array, I have like 1, 5, 0, 4, and 10, these elements. So if you want to access indexes this element, so you don't need to go from here like first access this, then this, then this, then this. No, you can directly access this. So I say direct access or random access is possible in array. How to access this element? Name of the array, suppose A. So A and index of this is 3. Just use this and you can directly access. How to access? There is a formula to calculate the address of this element directly. That also I'll tell you, don't worry, right? But for now, I think it is clear to you how you can access directly, right? And data manipulation. So various operations are there we will perform on arrays, like sorting, searching. These are easy to perform on arrays. So you can easily manipulate the data. You can access the data and you can easily manipulate the data, right? Okay. Now, how to declare an array. This thing, how to declare, how to initialize an array. This thing, let's see practically, and then you will get it better rather than theory. Okay. So let's create a new Java class here, and we are discussing what? Arrays. So let's name it like array demo, and in main, first we will see declaration. Declaration of an array. And simply you have to write for declaring an array. First, the type, data type of the array. Suppose I am taking int. So see, arrays can be of any primitive type. Int, double, float, boolean, byte, short, and we can have arrays of any class as well. We can have arrays of string, we can have arrays of arrays, we can have arrays of any class. That thing also I'll show you, arrays of string, arrays of class. But for now we will see arrays of primitive types. So let's take int, or let's take double. Double, and name I'm taking marks, that's it. So it is simply declaration of an array. And this is what? Object reference, right? So this is also fine. Or if you write something like this, I want to use these bracket in this here, this is also fine. But this, it's showing that local variable marks has C style array type declaration. So generally in C we use this thing, right? So in Java we use this. But you can use that also if you are comfortable with this kind of thing. You can use this also. It's fine, right? We will use this. So here no memory allocation is done. It is simply declaration. Means here the marks is only declared and does not point to any actual array in the memory. See, marks, I have told you arrays are objects, right? So it is basically an object reference we are creating. So it is not referring to any actual object in memory. It holds by default the null value until it is initialized. So it is just declaration, no memory allocation till now. Okay. Now you want to instantiate the array. How you will do that thing? So let me tell you that thing also. That thing will do with a new keyword. So here the syntax is, let's just comment out this thing, and the syntax is same. We use the data type, then this, then name of the array is equal to new keyword, then the data type, and here simply the size. Now memory allocation has been done, right? So marks is simply the object reference, and an array object has been created for 5 elements of type double, right? And right now the default value in that is 0, 0.0d. With default for d double is 0.0d. For float 0.0f. For int default value is 0. For boolean default value is false. For character it's /u 0000 something like this. So default value for double is like 0.0d, so 0. Right. Now we haven't initialized the array. This line is what? Instant. We have instantiating an array of name marks of type double. So memory has been allocated. Instantiation means memory has been allocated to this array. Okay. Now we are going to initialize the array now. Or for this, you can also write something like this. Just double and this marks simply declaration. Let's just tell me the second approach, and here marks is equal to, simply we can write down new and double, and we can give the size, suppose 5. This will also do the same task. This thing we have done in the same line, but you can do the same task in 2 lines as well. This is what instantiation of this array. So either you can use the single line, or you can use this thing in 2 lines. You can write down this thing. Instantiated this array. Now we have done this thing in 2 lines, right? So that is also fine. Array has not been initialized here yet. Memory has been allocated. So this line is what? Declaration of the array reference, right? Array reference is marks, and this line is what? Memory allocation with size 5, right? So here this marks, this points to the memory location where the array of double are stored. So it is just referring to that memory location. It is not holding the actual value, right? Now how to initialize an array. So suppose let's comment out this thing also, and we will now just use array initializer to initialize the array. Third thing is we are going to now initialize the array. So one way is how to initialize. Simply we will write down the same, like double, syntax is same. Name of the array we are taking marks. And one way is new, double, and here also we will give the list. How many element you want, like 34.5, 78, 99.8. Only 3 elements I want of type double. So this is int, but that will not give you any error. It will be like 78.0 promoted. So this is one way. This is array initializer. Whatever you write down here, like the list within these brackets, parenthesis, this is known as array initializer. Or if you don't want to write down this thing, we can write down this thing something like this. A more simple way is marks. Let's just comment out this. Otherwise, it will give you error, is equal to simply the list here. So the same list I'm taking here, and that's it. So this is the most simplest way to initialize and declare the array and instantiate this array at the same line, right? Three ways are there. It's just declaration of the array. Then we can use something like this. Then you have to assign the value, that also I'll tell you. But here I'm initializing the array at the same line, and this is array initializer. So array initializer is basically a shorthand way to declare, instantiate, and initialize an array in a single step. In a single step, by providing the values within these curly brackets. So now in this case, what we'll do, we are not specifying any size. See, here also there is no size. Here also there is no size we have given. So how the size would be calculated? Java will automatically determine the size of the array based on the number of elements you have given. So the size of this array would be 1, 2, 3. Size of this array would be, suppose I write here comma 89, would be 4. Right? Based on the element, the size would be automatically determined. Okay. Now, there are some restrictions also. If you think that I want to use an array something like this, let's declare the array and let's just initialize this something like this. Like, let's take this list only. What do you think? It will give you error. This is not allowed. Array initializer is not allowed here. This is, I have told you, this is array initializer. Whatever you write here in these, the array data, this is known as array initializer, and this is not allowed here. You cannot use array initializer something like this, right? Because this is what, though no memory has been allocated to this marks, it is simple declaration, right? And we are simply writing marks is equal to this. This marks is just an object reference, array reference. It cannot directly store these values of the array without actually creating an object. Here we haven't created any array object. So you have to create the array object first. Have to create, if you change this equal to new, you have to use. When you write new keyword, then array object has been created. Okay. Now the array object has been created. Suppose we have given here 5. Okay. Now the thing is, still you cannot use this array initializer something like this, like marks, the name of this object reference equal to this. This line will give is invalid still. So if you want to make changes here, so either you can use marks is equal to new double, and this you can do, or rather than writing here, you can just delete this semicolon. This is allowed now. Declaration of the array, and now we are creating the object and we are initializing using array initializer. This is allowed. Okay. So if we are using array initializer, this kind of thing, then this new double or this kind of thing is not required. If we are declaring and initializing the array in the same line, something like this. So in this line we don't require any new double or this kind of thing, right? But if you are not declaring and initializing in the same line like this, then you have to use this new and then data type and this array symbol. This is required in this case. Okay, so there are some ways to declare and initialize this array. So we can use, like we can say, we can only use this array initializer at the time of declaration. At the time of declaration, something like this. Now, this is what we have initialized the array and like this. But if we are not having this thing and I have just declared this array, something like this and something like this, not just declared, I have just instantiated this array something like this. Now I want to assign values. So there is one way how we can assign values. We can do something like this. I have told you we can do one thing. We can access the array elements with just the name of the array, like marks, then square bracket, and here the index. So index always starts from 0. So at 0th element I want to store 45.7. Then same, suppose at first element I want to assign the value 89.9. Then at fifth, not second, I want to store 89 or suppose 99.8. Only three values I have stored. So this is what we are assigning the values here individually to individual arrays at the 0th index, 1 index, second index. This also you can do if you have like less values, 3, 4 or 5 values. You can do this thing also. Individual elements also you can assign something like this, right? And now if you want to access, if you want to print, or if you want to access the array elements, then simply I have told you have to print in system.out.println. You simply write down the name of the array. Here we have name of the array marks. Then in these square brackets, write down the index. Suppose I write 1 here. What it will give you, the output? What do you think? Pause the video and think. What it will print? Let's run this. Select here the current file and let's run this, and it will print 89.9, I guess. So see 89.9, because 1 means we are accessing what element? The second element. Index of this is 0, index of second element is 1, so it will access, it will give you this thing. Like this you can access. Now suppose if you want to access the element at fourth index. So at 0, at 1, at 2 we have this, at 3 and at 4, because the size is 5. So how many element we can store? 5 elements. But we have stored only, we have assigned only, we have initialized only 3 elements. 2 are remaining. And I want to access 4, means the last element. What it will give you? We haven't initialized anything. So will it give you some garbage value or what? Let's run this and see. So first it will print 89.9 and then it will print 0.0. I have told you default value would be assigned. The default value for double is 0.0. See, when you go for search for primitive data types and when you go for this Oracle website, oracle.com, then it will show you the default values. Byte for 0, for short 0, int 0, long 0L, float 0.0F, double this, for string null, boolean false, and character this. So these are default values. So that's why you are getting 0.0, that is default value, right? And one more way, if you want to find out the length of this array, then there is a field length. You can use that thing simply in system.out.println if you want to find out length. So the name of the array dot, we have length. See, it's not a method, it's just a field, just attribute, something like this. You cannot simply use here this will give you error like this, method call expected, and it is public final in length. It's not any method, it's simply a final field variable kind of thing. So simply you have to use marks.length and it will give you 5. So it will give you here, see the length is 5, right? Now using length also we can access, like if you want to store this length somewhere else in some element, array length. So the marks.length is now in this variable array length and I want to access this. So marks, if you write array length, what do you think? What it will give you? Pause the video and think what it will print. Let's just comment out all these 2 lines and I'm just printing this thing. Let's run this and it will show you the exception I've told you. Array index out of bound exception. Index 5 out of bounds for the length 5. Because now in array length is 5, total element are 5. So the range is from 0 to 4. So if you want to access the last element, that would be array length minus 1 at this index. Now it will give you the last element, that is 0 only, because we haven't assigned anything. So the last element is 0. If you write down here something like this, like marks, and at fourth index I have assigned something, some value, 98, it will give you 98.0 at this time. See, 98.0. Okay, so like this you can find out length also. And what if I write something like this? Let's suppose I write here, I have a variable int n something is equal to 6, and rather than here I just write n. This thing is allowed. You can just write down any variable here, but that variable should have some value at first. If you simply have here is equal to this, it will give you error. See, variable n might not have been initialized. So you have to tell the size at the compile time only. You are writing n, there is nothing here in n, so you have to give the size. Either you write down some size of this value of this n, and now it will work fine. Otherwise, you simply write here 6, that will also work. Okay. Okay, one more thing I want to tell you. The type of this array is double, right? Now maybe you are saying, ma'am, you said that we can store same data type. So here we are storing int, not double. But the thing is, int is smaller, double is larger. So it will automatically promote this. So it becomes 98.0, that is double. That is why it will not giving you any error. But if I write here, I don't know it will work or not. Let's suppose L. So it will also work. Let's run this and see the output, what you will get here. So it will give you 0.0. Why? Because obviously we have done here 6, so that is 5. If you size is 5, then only at fourth index we have this value 98. So 98.0 only. So it will be automatically promoted to double. Long data type is smaller, double is larger. Okay. But if you take here, if you take here int type of array, let's just comment out this. I'm taking an int type of array, suppose int and numbers. Okay, so let me just use this only, and numbers is equal to, so I'm not taking this here the size. Let's just take the values only 1, 3, 4, and 6 and 7. That's it. So it can only have int values if you store here 7.8. See the error. Provided is double, required is int. So only same type of data is allowed. That is kind of a restriction in array. Mixed data type is not allowed. In Python it is allowed. Mixed data type is allowed in the list. You can store int in this even in the same variable name, string, int, double, everything in Python, not in Java. So in Java, in arrays, we can have only single data type. So this will give you error, this kind of thing. If it is int, you can have only int. You can take like short or byte because that can be converted to longer. So that is allowed. This thing is not allowed. And one more thing I want to tell you, if you give here -7, the size of the array is minus negative array size. Let's run this and see whether you are getting any exception or something like this. See, negative array size exception. You will get an exception. So negative size is not allowed. Right? Let's take 0 here. Let's run this. You cannot leave it blank. But yeah, 0 is fine. There is no size of the array. That is fine. But you cannot leave it blank. That will give you error. You cannot take here negative. If I take here 8, suppose L, this will also give you error. Provided is long, required is int. So here you can have only int type, positive. No long, double, float, nothing else. 8.8, this will also give you error. You can have only int. So 6, 8, that is fine. Now, while accessing, suppose just initialize it here only. Now see, this will also give you error. You have given the array initializer 3 elements and you are also giving the size. Both things are not allowed. Because when you give array initializer, then Java will automatically determine the size of this array using these elements. So explicitly, you don't have to give the size. This will give you errors. Let's just leave it blank and something like this. Now the size of this is 3 only. And if here you write here -1 is equal to 7, I want to assign this. See this also, array index is out of bound. Because obviously array index is 0, 1, 2 and -1 is out of bound. So it will give you an exception. Array index out of bound. Right? And here you take 1, it will work fine. If you take 1L, long number, sorry, 1L, it will also give you error. Provided is long, required type is int. Here you can always give an int because index will always be an int type from 0 till length -1, right? So you cannot write here any boolean or float or long value. You have to provide here in the index int value. This thing you need to take care. 1 is fine. So this is what? Now we are changing at one index. At first we have 5 and now it has changed to 7. So if you want to access this, so have to access numbers and 1. It will print you the updated value, that is 7. Previous it was 5 but updated is 7, so it will give you 7. So like this you can update this also. Directly you can update, you can access any element and you can update, modify that. One more thing you can do, like suppose you take an element, a variable short s is equal to 1, and rather than 1 here you can simply write s. This will also work fine. Short byte int are allowed here, and this is 1, so it will be automatically replaced by 1 and the output would be same, that is it will give you 7 only. Okay, so like this you can play around with this and you can just try out different kind of things with this array. When you will get error, when this will work fine. So this kind of thing you have to do now. Okay, one more thing I want to show you here is, let's just comment out these things. And I have an array of this and I'm not going to initialize this right now. I'm just giving the size to 5. Now I want to initialize this array at runtime, means from user. I want to take input from user, the array elements from user. So yeah, we know this thing. We have a scanner class. You can just create object of this scanner class, and now but you have to use here for loop because it's not a single element. Here we are initializing an array, so you have to provide 5 values. So let's simply print here first, enter array elements, and now you have to take a loop. Let's take the traditional for loop. There is a for each loop also, that also I'll show you, but right now let's take traditional for loops. Int I is equal to, index always start from 0, so I'm taking here a 0. We'll start from 0, then I should be less than till less than 5 because the length is 5 only. So 0, 1, 2, 3, 4. It will run till 4. Or if you do not want to hardcode this, you will just find out the length of the array. We know there is one field that we can use, dot length. It will give you the length of the array and I plus plus. Right? And here simply we can use what? The array name numbers have to access. Here we have to use I. The index is equal to scanner dot next int. Simple. So like this, we can populate this array at runtime. Means from user we can take input, right? And how to access the array, that also I have told you. If you want to print all the 5 elements, either you can print one ways, you can simply write down this line multiple time like this, and the name of the array numbers, and at index 0 what is there, and then like this we can print all the 4 elements. So let's just run this first. So it will first ask you enter the array elements. So it is asking me enter the array elements. I'm entering here like 5 elements we have entered, and it will print all the 5 elements like this. But rather than writing, obviously this is not a good way. The same line, this is repetition of the code. Why to repeat? Why to write down? Why to do the duplicacy in the code when we have the loops? So the same line we are repeating. So just put this line in loop. Just iterate the loop from 0 to 4, because 4 till now you want 5 numbers, 5 lines you want. So from 0 to 4 we are going to iterate the loop. Let's just copy paste the same loop here. From 0 to numbers dot length I plus plus, and rather than taking the input, I'm going to print this. But rather than 1 here, you have to use I, because I is changing. I was first 0, then I plus plus means 1, then 2, then 3, then 4. So let's just comment out these lines. Now see how compact our code is. We have just done these, we have replaced these 5 lines with these 2 lines, loop and 1 line. Okay, let's run this and see you will get the same output or not. So we are just entering the array elements here. 5 elements I have entered, and you get the 5 elements 4, 5, 6, 7, 8. So like this we can initialize the array at runtime also with the help of scanner object. And like this we can print or you can access the array elements. Now let me show you how these memory representation of this array. So this thing we have covered different ways to declare an array. This thing I have all told you how to initialize an array. This is instantiation of this array like this, and initialization of the array something like this. This thing we have seen practically. What is array initializer? I have told you. This is what array initializer, right? So like this, we are initializing this array with this. Now memory representation of an array. This thing let me show you practically. I have told you in Java arrays are objects, right? Means when you are creating instance of a class, like same way we are creating arrays, object of arrays. It's same kind of thing. And when you are creating object, so the objects are stored in the previous lecture I have told you in heap area. There are two memory areas, stack and heap. So same concept will be applied in arrays. If we write something like this, if you write this thing means whenever you write like new keyword in this means memory has been allocated. We have instantiated this array means there are two memory areas. One is like heap. So this is like dynamic. It can shrink and expand. And one is, this is what like stack, something like this. So in heap area, object, one object has been created of this array somewhere, right? And numbers is what just in this array reference. Arrays are objects. So in stack, obviously this would be in main method. So whenever you call a method means stack memory is basically used for method calling and for local variables, to store local variables. So whenever any method has been called, then in stack, one stack frame has been pushed. This is for main. In the stack, this is main frame, main stack frame. So here, whatever the local variables for this main, those would be stored, and something extra information also, but that is not of our use. We just take care of this thing, whatever we are right now using in this case. So here in this main, we are having an array, like this is the local array reference in this main. So here we have some like for numbers. So here we have some object reference, and that is going to refer this object. Some address, suppose I don't know, 1000 like this. There is no actual value in this object right now because we have just created the object, and that would be in heap. And the address of this object, like base address, the starting address of that memory block, how much memory? 5 into like how many bytes? 5 into 4, that is 20 bytes, we say, right? But in deep, if you say, then there is a array header also here, and the actual values also. And for array header, that array header contains the length of the array and the type of the array. Okay, here. So two things are there. Array header as well as the values. So array header is also going to take some bytes, but that is at like low level kind of thing. We're not going to go into that much deep because all the memory handling is done by Java itself. We don't have to give that much detailing to memory. There is garbage collector, there is automatic memory management in Java. If you're working in C and C++, then you have to deal like at low level because we deal with memory ourselves. Okay, in Java that is not a case. So basically like 20 bytes has been allocated and the base address or the address of the first block is there here. So it is going to refer to this. Something like this is happening. And now when you initialize this array, suppose I have initialized this array. Here I'm not taking here 5. Just remove this. Something like this I have initialized this array. So right now how many elements? 1, 2, 3, 4, 5. So in this array object, there are something like this. So let's just remove this. It's just a visualization. It's not actually like in memory it is happening, just a visualization purpose. Like 3, then 4, then 5, then 6, then 7. And suppose address is 1000. So next element would be stored at which address? 1004, then 8, then 12, and then 16. Like this. Because one element is going to take 4 bytes because it is of int type. Right? If it's double, then I guess it will take 8 bytes. For character, it will take 2 bytes. For boolean, it will take only 1 byte. But it is int, so it is going to take 4 bytes. Like this. So now it is referring to this array object. So actually, this is an object. Array object. Actual values are stored in the heap area. This is heap area. And this is just the array reference or the array object reference, which is stored in the stack and having some address. Obviously, this will also have some address like 81234 in hexadecimal form. And it is containing this address of this, basically reference, or you can say the memory address of the that array object. This is how actually happening. Not actually exactly, we don't know, but to somewhat I can say like this is happening behind the scene. The memory representation of an array. This is the case. Heap area and stack area. Okay. Now, if you want to access any element here, so I told you simply go for the index, and index is 0, 1, 2, 3, 4. Index start from 0. How to access this and how that address would be calculated. If I want to access this one, sorry, this. So what you write here, the name of this array like numbers and the array index that is 2 and it will give you 5. Now what is the formula? How this address, because internally at the runtime there is only the address and the value. Compiler will check the address only and at that address whatever value is there it will fetch that value and it will give you. So at runtime basically it's only the address and the value, that's it, nothing else. No name of the array or something like this. So how actually the address is to be calculated? What is the formula? How to access these elements? Actually, what is happening? So the formula is, if you calculate this thing, so the formula is the base address of the array. In this case, the base address we have taken 1000. So the base address 1000 plus whatever the index you have given. Index I have given 2 here, so 2 into whatever the size of each element. It is of type int, so size of each element is 4 into 4. So it will give you 1008. So whatever is there at 1008, it will give you that value. At 1008, we have 5, so it will give you 5. This is the formula. So in general, if I write the formula, then that is like base address. Have to calculate the address. Have to find out the address of element of an array. BA is base address. Okay, it's not equal to plus index number or index simply into size of each element. It's not size of like array or something like this, size of each element. So each element is of type int, so size of int is 4. This is the formula to calculate address of any element. If you take any element, you will get the actual address by applying this formula. If I write here, suppose numbers and 4, then base address 1000 into I is 4, sorry, the index number is 4, into size is also 4. So it will give you 1016. At 1016, what is there? 17. So it will give you, sorry, 7. And that is correct. At numbers 4, we have 7. So that is correct. So the formula is this to access the element, right? And because of this formula, there is one reason that why index starts from 0. Maybe you are thinking, why index start from 0? Can't we start from 1? So there are mainly two reasons. First is that historical reason. Next is some technical reason also. So historical point of view, if I say, then see, there are many languages in which we have index start from 1, array index start from 1. Like we have Pascal, sorry, not Pascal, it's like Fortran we have, Smalltalk we have, Lua we have, and then we have R, MATLAB. So these languages, array index start from 1. But like C was the one of the earliest and the most popular language, C, right? And it started using index of the array from 0. The makers of C done this thing because of some reason, right? Because in C we have pointers. So in pointer arithmetic we do. In pointers, when we perform some arithmetic operation plus this kind of things, then if array index is from 0, then it will be easy. Okay. Now Java is heavily dependent or influenced by C and C++. So that's why makers of Java also inherited that concept only. Like we will also start this thing. Array index would be from 0 only. Okay. Next is when you are going to calculate the memory address, then it will give you a clean and simple kind of thing. See here, we calculate base address something like this. If array index starts from 1, then you write here 1. Okay. 1 into size of each element. So to find out the exact address, you have to again subtract something from this, right? Suppose array index start from 1, and if I write same hit num2, so what it will give? 1000 plus it's 2 into 4. So it will give you like 1008. At 1008 we have this, right? And array index start from 1, like 1, 2, 3, 4, 5. Number 2, I want like second element. Second element is this, but it will give you the third element at 1008. So you have to do some minus kind of thing also, subtraction also from this formula. So that would be like one more step added to this formula. Okay. And if it starts from 0, then it's simple. Index is, it's not the position of that element in this array, it's basically the offset. It's basically the offset from the array header. Offset means the distance from the array header. How many steps you are there from the array header. So for the first element, this is the first element, and this is the array header, obviously, the starting of the array. The offset is what? Nothing. You are at the array header only, the first element. So there is no offset. The distance is 0. So that is why basically index start from 0. It is more of offset. It's not the position kind of thing. It shows the offset. Means from the array header, the distance. So for the first element, the array header, and between the first element, there is no distance. There is no offset. So that is why it is 0. For the second element, the offset is you are one element apart from the array header. So 1, then 2, then 3, then 4, something like this. Right? And like in some another data structure also, list and something else, there also index start from 0. So they want to make it consistent with other data structure also, so that Java developers don't need to remember like array. In array, the index start from 1, and in other data structure index start from 0. So they made it consistent with other data structure also. Okay. And while like computing, I told you this memory address, these are something like we are dealing with addresses, not exactly addresses, but yeah, it's pointer arithmetic. This is nothing but address, right? So when you are dealing with pointers, when you do pointer arithmetic operation, then it would be easy if the index start from 0, if the offset is 0 of the first element. Otherwise, you have to do some extra calculation. Like I have told you in this case, you have to do some extra subtraction step to find out the exact element. Okay. So that's why index starts from a 0. Fine. Now I hope you got the memory representation, how to access elements, array elements, the formula, and why index starts from 0. Let me show you something practical. Okay, one more thing I want to show. If you just declare this array, just this, and I just want to suppose print marks, it will give you error. See, variable marks might not have been initialized. But one thing I show you, let's just comment out this. Okay, first copy paste this thing, and let's declare this array at the class level. But that would be static if you want to access this directly, static. Now see, there's no error. But the thing is, implicit call to string on array marks. Just leave it. Let me just show you the output first. See, null. Null is what? It's a literal. And string value by default is null. So that's why it is showing you that was like toString, this kind of thing, like implicit call to toString and on array marks. Okay. Now the thing is, I've told you this is what? An object reference. And if you do not initialize it, if you do not instantiate this, then by default it is having null. The object references are having null. So that's why it is printing here null. But here it was local variable. It was local variable in this main method, and local variables do not get values, by default values. This thing we have seen in previous videos also. But these are class level variables. So this will be having the default value. So default value for object references are, because array is what? An object only. So object reference, it contains the reference to the actual object of the array. And this will give you null only. Right? Now here, if you just take this static array, something like this, and here also you can allocate the memory, something like this, marks is equal to, by using this new keyword, new and marks. Sorry, it's new marks now, it's new double, and suppose 5. Right. Now again, if I run this, then it will show you some address. See now, it is nothing but, don't get scared, it is just address. This bracket means it's an array. This D means it is of double type. See, it is of type double. And at the rate means this is the address. Now at this is some hexadecimal form. At this address, the actual array object has been created in the heap, and that address is in this marks, that reference. So this marks is referring to that actual array address, right? If you change this to int, what happened? If I change this to int, like just printing marks, now you run this and see now. Address is this, but here now I means int. So D was double, I means it's of integer array. Fine. Now you can initialize this array. Same method, you can take something like this also, or you can here only you can use array initializer, or rather than writing new int, but directly here you cannot use array initializer because marks is equal to array initializer. This is not allowed. This thing we have already done. I have just removed that thing, I guess. So that is not allowed. If you do something like this here, if you comment out this thing, and if you are writing marks is equal to, let's initialize with some marks. This will give you error because array initializer you cannot use something like this. This is not allowed. Yeah, that is fine. You have to write down here this and then array initializer is allowed. So this is simply you can use in array declaration. In array declaration statement, this array initializer. You cannot use as an assignment, reassignment statement. The previous was an assignment statement, right? Marks is equal to this was an assignment statement. So that is not allowed. So I guess you got now the memory representation, all the three steps. We have discussed this with example. Accessing an array, that also we have discussed how to access array element, how to calculate the element address. This is the formula we have discussed, right? Why index start from the zero, that also I have told you. Now, how to take input from user using scanner class, we can take input from user like this, like in a for loop. So how actually the thing is working here, see. So if this so if this is the case, then what is actually happening? This is the array, this is array reference in stack. There is an object in heap. The size is how many bytes has been allocated? 5 into 4, that is 20 bytes for that object. And the reference of that object is stored in this array reference num, which is in stack. Now, in for loop, first I. So this is a I variable, right? It is in main. So in that main frame, we have this num reference plus another variable we have, that is this is local variable I. So I in I we have 0 at first. I less than num dot length calculated, then it is 5. It will be 5. So yes, condition true. Then we will enter here and num at I. How this would be calculated? Num is what? 1000. Suppose 1000 base address is 1000. So 1000 plus I is what? At 0 into size is 4. So only 1000. So at 1000, whatever would be stored? sc dot next in. Whatever you will enter using scanner class, using scanner object, that is sc. Suppose scanner object is sc. That will be stored at this address. Suppose we have entered 3. So that 3 would be stored in that 1000. Something like this. I plus plus, now I becomes 1. Condition true, again enter here. So at num I means here it would be 1. 1 into 4, that is this. So at 1004, whatever next element you will enter, that would be stored. Suppose you have entered, user have entered 10, so that would be stored. Something like this. This array would be populated till this loop will run till 2, then 3, then 4. So suppose 11, then minus 1, and then 0 we have entered. Once it becomes 5, condition is not true and out of this loop. Same for printing also. Same loop, but rather than this line, we are simply printing like system.out.println and whatever the array, and here I. Simple. So like this, only the address would be calculated. At first I is 0. So for num 0, here we have 0, address is 1000. So the compiler will check, like the JVM will check at the address 1000, what is there? 3. So it will print 3. Then for num1, I plus plus becomes, I becomes 1. Condition is still true, less than 5. Then for num1 addresses 1000 plus 1 into 4, that is 1004. So it will look at 1004. What is the value? That is 10. So 10 would be printed. Like this, we are going to fetch the value one by one. Right? Using loops, we can take input and we can also print using scanner class. Printing array element, this thing I have shown you how to print. Or you can use enhanced for loop also. This thing we will see in next lecture. This is basically for each loop. Okay. Here there is no condition or all. You simply take a variable like int element, then colon, and then whatever the name of the array, that's it. And simply print the element. So one by one, whatever the array, the first element first would be stored in this element and that would be printed. Then second element would be stored in this element, in this variable element, and that would be printed like this. So till length of the array, it will run automatically. You don't need to give any condition and something like this. That is why it is known as enhanced loop or for each loop. You don't have to remember here like the condition, no, I plus plus, nothing else. Simply take a variable and in colon, after that, whatever array name, just put that thing. So one by one, the array elements would be assigned one by one to this variable, whatever the variable is here, and you simply print that variable that is working of this for each loop. Now, the basics is clear to you. Now there is some exercise for you. You have to create an array of integer and find the maximum value in that array, and you have to print the maximum value. Suppose array of 5 integer or 3 integer or 4 integer, and let's find out the maximum value. It's, I think, a little bit tricky, but if you can try it out, we can just do some exercises. If you don't get it, don't worry. We'll do these kind of exercises. Right. For now, you can just simply try to create different types of arrays. Int array, float array, double array, boolean array, short array, byte array, and long array. All the primitive data types arrays you try to create. Not just restrict yourself to int or double array. String also you can try to create. Okay, string is, it's not primitive data type, it's object reference. Okay, so array of those objects also we can create. Fine, that also you can do. What are advantages of using array? Simplicity. It provides a straightforward and easy to understand way to store and access data. Arrays are simple one, these are not tough. You have seen that thing. Okay, then obviously these are optimized for memory allocation and accessing, like we can faster access the data. Store arrays elements are stored in contiguous memory allocation, so you can directly access any data randomly. So that's why it will like faster execution or faster accessing of that data in arrays. Okay, arrays can be used to store various data types, whether it's primitive data type or objects references data type. Array can store anything. Fine. Now, what are some limitations? These also we have discussed. Arrays are of fixed size. You can store only same type of data in array, and out of bound errors are also there. If you want to try to access array elements that is not within the range, then it will give you an exception. And data type restriction is also there. Same type of data you can store in a single array. You cannot mix the data types. Okay. Now, when you are using array, then you need to take care of some things. What is that? Array, always initialize an array before using it. Try to use this thing, because if you will use uninitialized array, then it will give you some default value or some unexpected kind of thing. So initialize the array first, then use it. Always check the bound. Always give the index in the range. Otherwise, you will get out of bound exception. Okay. So you have to take care of the boundaries also, the range. Then data type consistency. You have to ensure that all the elements in the array are of same data type. Otherwise, you will get error. Fine. Okay. Now, you want to debug the array. If you want to debug the array, then you can simply use debugger. I have shown you many times. Just add some breakpoints and see how actually the control is going, where the program is working. So you can use debugger, or you can use multiple print statements. If you update something, after that just print something. Okay, so that after printing you will get the output. Okay, this is the output, so maybe you are not getting the expected output, right? So if you use multiple print statement, at some points if you print the output rather than at the end, then you will get to know easily that where you are, you know, having some error. Like this you can use, or whatever error message you will get, just read that message properly and then according to that resolve that error. These are some things you can try out. Okay, now array example is storing student grade. You can just create a program in which you are going to store the students marks or grades. This thing we have already seen, so you can do this thing also just for your practice. Fine. Marks would be maybe in float or in a double you can take, or an int also you can take. Then you have to take the marks from user using scanner and print the marks using for loops, right? So that's all about the basics of arrays. We will see something more about arrays in the next lecture, but till now you try out. Now try to create different size and different types of arrays and do something. Initialize the array, then Don't initialize that. Take input from user using scanner. Try to use these things. Okay. So more about arrays we'll see in next lecture. So now I'll see you in the next lecture. Till then, bye bye. Take care.